All right, so here are a couple of problems that we're doing where it involves every kind of shift we can think of. Horizontal, vertical shifts, and vertical stretches and compressions, and reflections as well. Okay, so let's just kind of go through all four of these here. And I'm going to use this acronym I made up called rigorous. Okay. And what it stands for is, R is realize or recognize what kind of function I'm dealing with. For number 5, it's a quadratic, which normally starts at 0, 0, and goes up like this. Okay, and G is the graph, which I just made the graph. R is reflection, and I look for a negative in front of there, and I don't see a negative. Okay. The first S is for shift. Okay, so I notice that there's a -1 with X and a -3 on the outside, which means I need to go to the right one because we do the opposite of what's with X. And then we go down 3 because it's -3. So the vertex of this parabola is going to go to the right one, down 3, which is down here. Okay, and then the last S is for a vertical stretch or vertical compression. Okay, and the 2 tells me it's going to be vertically stretched, or it's going to be a little bit more narrow, or the slope of each side of the graph is going to be a little bit more steep. So when I graph this, it's going to go a little bit more upwards than normal. Notice how it's a little bit skinnier than the orange graph. So that's what number 5 looks like. All right, number 6. Recognize what kind of function this is. This is an exponential function. Okay, so normally I'd put it here at 0, 1. That's my critical point, and then it goes up like this. Okay, then I have the second R, which is reflection, and I do reflect because I see that I have a negative in front of the 2 there. So I reflect the whole graph over the x-axis. So see how it kind of reflects there? It's like a mirror. Okay. So it's a -2, and then I do my shifts, which I see I have a couple right here. So that means I go to the left 3 and then up 1. So left 3, up 1 means I'm here. So my new graph will go right here, something like this. Okay, and there you go. There's that one. All right, number 7. So it's sine of x. So normally for a sine graph, it starts at 0, 0. At pi over 2, it's at 1. At pi, it's at 0. At 3 pi over 2, it's at -1. And at 2 pi, it's back at 0. And normally would look like this. All right, thank goodness there's no horizontal shift because there's nothing with x. But I do see that there is a +1. Okay, so that means all the points move up +1. Okay, so all my points will move up to +1. Okay, but here's the new thing here. So now I have a 2, which means it's going to be a vertical stretch. Okay, but notice how I moved all the points up 1. Okay, so my new kind of middle line is right here. Okay. So when I put that little dotted line there, what I want you to see is that is where our stretch point is. So if the point is on my new kind of middle line, they don't stretch. So here at 0, here at pi, and here at 2 pi, my graph isn't going to move. But from here at pi over 2, it's actually going to get stretched up here to 4. All right, and this point here at 3 pi over 2 gets stretched down to -2 down here. So my new graph is actually going to go here. Okay, and it's really key that notice how I moved all the points up 1. That means my new kind of middle line, or the place where my graph will always kind of repeat its pattern around, is at 1. So that is where I do my stretching. I stretch from my new midline, which in this case is 1. So on number 8, okay, it's another great example here. Let's first look at cosine. Cosine usually starts here at 1, and then at pi over 2 it's 0, at pi it's -1, 3 pi over 2 is at 0, and 2 pi it's back up to 1. So it looks something like this. Okay, there's no horizontal shift, thank goodness. But I do notice that there's a vertical shift down to. So all the points are going to move down to. Oh, wait, Mr. Schwant, silly Mr. Schwant, before we even do the down to, let's take a look at, there's a negative in front. Whoopsies. So it's going to reflect this whole graph going the other direction. Okay, so it's going to go up first, then down. Okay, so up first, then down. And then let's do the -2 shift. Okay, so all the points are going to go down 2, down 2, down 2, down 2, down 2. There we go, much better. Okay, so I always do the reflection first before you ever do any of the horizontal or vertical shifts. All right, so there's the green graph there. So there's a quick kind of run through of 3 different types of equations, and I hope that video was helpful.